Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. I am your host, Dean Phillips. It is my distinct pleasure today. I have Erin Bishop, and she happens to be Senior Consultant in Market Research at Machine Inbound. Welcome, Erin.
Thank you.
It's great to have you here. Right off the bat, what do you see changing over the next 5 years in technology?
Well, with President Biden's focus on improving automation and manufacturing in the U.S., I think there's going to be a lot of companies looking to home shore operations, and automation and robotics are absolutely needed to be involved.
Great. I think you're right. I think it's something that we're going to have to do to help address some of the workforce challenges and things like that. Tell me a little bit about your background. I know you're also an angel investor, and what got you involved in technology?
I'll put it this way. I'm very grateful for STEM education programs. Mm-hmm. I was very involved in this program called First Robotics, and it still goes on today. I was in high school. It was the year 2000. I'm an old millennial. I'll put it that way. I'm somewhere straddling between millennial and Gen X. But there's this funny demographic who was born in the early 80s, where when I was in second grade in 1992, that was the year my elementary school bought the Apple II and put it in the classroom. And so my generation grew up with the technology as it was becoming more available. Fortunately, I did not have access to social media until my brain was fully developed. I was in college at that time in 2005. But in the year 2000, I was in high school. And in the 90s, this program called First Robotics was started by Dean Kamen in New Hampshire. Dean Kamen is known for inventing the Segway, which was a fun story. And I just felt like I found my thing. My dad was an aerospace engineer. I had no idea what being an engineer meant. He worked at Pratt & Whitney in Connecticut. And I was good at math and science in high school, but I wasn't sure how I wanted to apply it. And so I did First Robotics, and I fell in love with robots, so to speak. And so I was 16 or 17, about to apply to colleges, and decided that I wanted to get into robotics because I deliberately saw it as a market in an industry that would be growing over the course of my lifetime, and I wanted to influence it. On the manufacturing front, I went and studied industrial and mechanical engineering, and so many robots were being applied to manufacturing, but also there were many manufacturing processes that were not yet automated. So I began asking myself the question, what robotic or vision or deep tech technologies would be required in order to automate these things that are not yet automated?
Mm-hmm. I can tell you, I'm a huge fan of First Robotics and Vex Robotics competitions, and mm-hmm. they are outstanding. I think anybody who has an opportunity to get involved in it, whether it's to be a judge or whether it's to actually be a competitor in those, please do it. You'll find that it is such an incredible opportunity to see so many young people getting involved in this, and what they do and the outcome of those events is tremendous. It changes the people that I know forever.
And what I'll add is you do not need to have a school-age child to do this. My father, he's retired. He's involved with his local first team over in Houston, Texas. Mm-hmm. And I go help out with regionals sometimes, usually as a judge or a robot inspector. But 100%, I would not be doing what I'm doing today if it were not for First Robotics. Great.
Yeah, I couldn't echo that more. It's a great opportunity. So that's how you got involved in the technology. What do you see changing from when you got involved till today?
Well, there's been a bunch of enabling technologies that were pushed forward by various internet companies. Also, hardware is getting cheaper. But there's people keep saying that, robotics is just around the corner, and they've been saying that for decades. And there seems to be a mismatch between legacy robotic systems, the ones that work today. In order to push those as new capabilities, they actually needed the technologies that the internet companies had. When I say that, more machine learning, data sets, computer vision very much hinges on data sets and processing. What Nvidia, I don't think anyone in industrial robotics was anticipating that Nvidia's gaming chips were going to be the thing that helped unlock a machine, well, Nvidia and others. But nobody in robotics is looking at video game electronics or video game GPUs and assuming that's going to be what unlocks the machine learning and computer vision, and that unlocks more robotic behaviors. So it's really an inter-industry play. And the other thing that's pushing a lot of technology forward is this push for self-driving cars in the past 10 years. I'm a little bit reluctant that self-driving cars will be available to the masses anytime soon. Maybe it's because I've been in robotics a long time and it's a hard problem. However, there's a technology fall off. They're looking at the new, it's to compare it to an Apollo program, the Apollo program, where so much technology needs to be invented and there is a lot of money to support that invention, that those technologies are now available to use in other types of robotics applications. So we're seeing a lot of new technology become available, a lot of hardware get cheaper, a lot of large companies supporting tools to make the stuff work, like NVIDIA's Omniverse is available to go program high-fidelity robotics and simulation systems. And the result of that is there are a lot of robotic startups who actually genuinely do want to solve manufacturers' problems. And with the lower cost and with the improvement in performance, these systems are meeting an ROI and labor shortage. These systems are now becoming an appealing return on investment for manufacturers.
Yes. Now, an interesting word you used there was availability. And when I think about availability, it goes hand in hand with affordability. Mm-hmm. And when you look out there and you see how some of these robots, how much they used to cost and how much you can reasonably purchase one, or even today they even have them for lease or rent, mm-hmm. which makes it a little bit more easier to get into and easier to use them within a manufacturing facility or just any type of a process. What challenge do you see as far as the hard part in the old days was who's going to program it? What changes do you see in the programming softwares now that make that more of an open door opportunity?
There's a couple of angles to look at that question. One, back in the day, you needed to almost hard program the robot to go to the same spot every time. And so there weren't many, I'll put it this way, maybe a good analogy is with the internet. It's, back in the day, you needed to hand code your own HTML to make a website. There were no tools. You needed to go in and type in command prompts into your computer in order to do stuff. It was a long time ago. And now you don't really need to program anything or type command lines for anything. You open up the tool, you drag and drop things. With robotics, really hinging on computer vision, where the robot just has to see the object, if it knows that the object it wants to grasp because it's been in a simulation environment, in theory, no one needs to program the robot. The robot should be able to program itself because it understands its trajectory. So a good place to get started, I'm going to do a couple of shout-outs to some companies, but I know Formic, F-O-R-M-I-C, they are a marketplace, or they help you select among there's 20 or 30 or many different types of different robot vendors that they work with, and they help make all of these robot vendors a RAP service, so robots as a service, where with collaborative robotics that are lighter, so they're easier to ship. There's not a huge expense getting a forklift to unload a pallet. They can ship it via UPS. And then the easier low-code, no-code robot interfaces. Machine tending is solved. If you need that, just go buy a cobot and have someone help you install it. That works really well. That's a really great place to get started, is have these companies help you identify some low-hanging, simple projects where you can get a collaborative robot arm in the door. The programming is either a combination of computer vision or drag and drop interfaces. There was another company that does really good. Robotics. Robotics. They have really great drag and drop simple interfaces, so people on the floor can reprogram. Imagine if you're using a cobot for machine tending, the part you're machining is going to change every couple of days or weeks, maybe more frequently than that. So the staff can get trained, and it's for simple tasks. The robots are ready, and they're at the right price points now.
Yeah. One of the first robots that I actually saw a lot of the drag and drop that really got me interested in seeing some of that stuff was when they had the Lego competitions, which you just dragged and dropped whatever action you wanted that robot to perform. And they were very limited, but the nice thing is that you had you had to have no programming ability. And, and I think a lot of people realized, I mean, if you go back to where computers were in the 80s, well, how did you program in the 80s? It was you had to know code. You had to know what you were typing in order to use a computer. Well, graphic user interfaces changed all that. And I think we're in the same spot now with robots. Do you feel like that's more the case, that we're trying to make these user-friendly so that it's available to anybody, not just programmers, not just robotic specialists?
100%, but here's the caveat. It's easy to program if the application is easy. So one of the complaints about collaborative robotics is it's so simple that it's difficult to make it do the hard thing. So the best thing to do is to go, if you have a process that you would like automated, there are a lot of experts out there. Just go and make their life a little bit easier. Tell them exactly what they need to know about your process or send them a video, honestly, even if it's a video of somebody doing it manually. What you want is all of this expertise coming back at you and saying, you need a cobot or you don't. This is how much it costs, or this is hard. You're going to need professionals to code that up, or a low-code interface. It really depends on the complexity of the task.
Right. I agree with that. I think that some of the AI in the robotics world that's been taking place, where on a few of the colleges where I've seen them doing some of these studies, is that it's one thing when a robot understands and can do the same thing over and over. So they do a demonstration where they're picking up corks. They're just picking up corks, and that's fine. But then they have to pick up a pair of pliers. It's a different shape. It has a different center of balance. It has a different requirement for torque and for how much energy it would use to lift that up. And how high you have to lift it. All of the range of motion things, those challenges, I think, are slow in performing improvements. How do you see that changing? How are we going to overcome some of those challenges?
So it's funny you mentioned the pliers, because it talks about the gradient of complexity of a picking task. So what works well today is you have a bunch of corks in a bin, and maybe you don't care about how that cork gets placed. Maybe you're putting them on a conveyor, or maybe you're putting it into some kind of singulator that shakes them or moves them around and gets them into the same orientation eventually. But the graph, there's the pick and then there's the place. The robot needs to pick the piece. And it doesn't matter where it picks, it's simple. If it's a plier and you have to pick it in a precise location, that's a lot more complicated. So if you can pick it up in any location and then drop it into any location, that's automatable. If you need to choose a grasp position, and this is what's working for these robots like Plus One, Dexterity, and Ambi Robotics. Those are three great real-time 3D computer vision pick-and-place companies. What they're doing is they are looking at a mixed, either conveyors or mixed tubs of different parcel sizes, parcels between 1 pound and 5 pounds, boxes, bags. There's issues with shininess, issues with grasp point. If you imagine 2 white apparel bags right next to each other, a system needs to be able to see and segment where the edge of those bags. Like, how do you know where one bag ends and one bag begins? So that's all more of a grasp position. Yeah. So on the pick, they need to look at the 3D contour and choose a place for the robot manipulator to go to the object and pick it. And that changes every time. So that for every new box and every new bag, you need to create a new grasp position, and that takes processing time and creating meshes on the computer vision side. Now the place is hard because once you pick, you have 6 or more sides to place an object, and so that gets really complicated. I'd say picking in a certain place is easy enough. Placing is hard. And that's where these different applications can, an application expert can go in and explain where your expectations actually are, or what's actually possible.
Yeah. I think the more open source kind of systems we have, the better that's going to improve or exponentially improve the timeline for some of these robotic applications. I look back at how drones were when they first got started. There are millions and millions of dollars in research put into every one of these cheap robots because it was the years of research of how do we counterbalance this, how do we analyze it, and quickly make a decision of how fast this rotor should spin in order to keep it level. And I see the same kind of situation now with some of these robots. If we can learn from each other's missteps or improvements, I think that can greatly enhance how quickly we can get to a perfect, I don't want to say perfect model, but a greatly improved model of software that can help us solve those problems you're talking about.
Well, yes and no. Actually, I have a little bit of an oddball point of view on open source robotics. And I'll put it this way. If you watch Tesla AI Day and somebody, and they're doing all of this great simulation computer vision work for self-driving Teslas, and somebody asked Elon, will you make this open source? And Elon's like, no, this is the most advanced engineering on the planet. Someone needs to pay for it. And what I keep seeing over and over again, first of all, if manufacturers that listen to this podcast, I think open source is a little bit too in the weeds. There are lots of great vendors to explain the end use cases and the capabilities. And at the end of the day, a manufacturer is going to need a vendor to hold them accountable. On the development side, I find often that when companies need to meet product expectations and need to meet customer demands, their well-funded internal R&D teams tend to develop what is actually needed and actually robust a lot more efficiently than the open source community. Because one, the open source community isn't as funded, and the open source community isn't often as incentivized to do this right. Whereas companies, they're on the hook. Right. They're actually 100% on the hook to deliver a functional, fantastic system.
And I think that's a fair assessment of it. I think when you're trying to solve something that everybody's trying to solve, that's a little bit easier. But when you start getting down into specifics, it is very difficult to make that happen, because what's really going on is that in an open source world, they're only dealing with whatever they're dealing with. They're not going to deal with your specific challenges or the specific challenges you're looking to solve within your application. And there's so many, I think in robots, one of the big challenges is that we want them to be able to do everything, from the most simple thing to the most complicated thing. And we believe that should just, well, it's a robot. It should be able to do that. It isn't.
Right. And I would, and to that note, some people in the research world, they know about this, like ROS, which is open source, and it's a fantastic community. I'd say where ROS and open source really makes leaps and bounds is the research community, the PhD students, that all the universities can easily collaborate on projects. And then what happens is these university students, these PhDs, when they graduate, they go take that general knowledge from building on top of ROS, and they go apply it to the company's internal stack and take the next level there. What I wanted to say was, maybe I had another comment, but I forgot, unfortunately.
No problem. It'll come to you.
Yeah. Right. Maybe you can repeat what you just said. I'm so sorry.
Well, I think that we expect robots to both solve the simplest to the most complicated.
I remember now. When you ask about the details matter, think about, this is where machine vision and training sets come into play. That, let's say you want a robot to pick up a mug with a handle. And a mug with a handle is only one of tens of thousands of types of objects in the world, maybe more. And the grasp positions are almost infinite. And you have to think about the physics. So gripper technology is still not very, like force control gripper technology is where the research domain is right now lies. That's not a solved problem. Grasping is not a solved problem. Force control is not exactly a solved problem. But the specifics lie in the data set generation in order to train a model and then train the grasp positions that can meet these models. So maybe a way to think about it, you think about all manufacturers on the planet and all the components they are assembling. Millions and millions and millions of components that need to go in a certain place. Each component needs, if it's a highly variable task or a highly variable assembly task, every component needs a training data set with its grasp positions, and probably some force control if it's a kind of a force felt assembly. That's why I do not make a bet that robots will be able to do everything. We still need people in the loop for a lot of these jobs.
Right.
And I don't want to, I have a little side project where I'm working on a book called When the Robots Don't Work. Mm-hmm. A little bit of a tongue in cheek, or like the robots might, go on strike, but I want to, like I'm doing today, talk about the real line in the sand of what robots can do and what robots cannot do, because I don't want to disenfranchise our workforce with the rumor that robots are going to take all jobs.
Right.
What's going to happen if kids hear that, they're going to stop studying math. They're going to start, getting bad grades. You can't disenfranchise children at 10 or 12 years old with these rumors, because the truth is, if they stop educating themselves because they think there's going to be no jobs, they have shot themselves in the foot, and they might not have a great career in their life.
Yeah.
But we need to have a more realistic narrative that the issue with our jobs right now is there's increased market demand for everything. It's an abundance problem. Everybody wants more. Everybody wants to eat more. Everyone wants to buy more. There are more people and more rich people to eat more and buy more and want more services. And there's demographic inversion where the most wealthy generation in the human species ever, the baby boomers, will be ready to spend their money and consume, and we don't have enough young people to support them. Mm-hmm. That basically everything's growing and getting bigger, and we're going to need workers.
Right. And that is true. And I mean, I think that's a very important point within this the workforce development challenge that we have today. And it isn't that simple to just say, well, robots will solve all of our problems, because it's really not that realistic to expect that to happen. The other part of it, go ahead. I'm sorry.
Right, and yeah, and I want to say to manufacturers listening to this podcast, get started. Like what's going to happen is you're going to have a workforce who needs to think about the big challenges. There's always going to be something that needs to be fixed, or something that needs to be attended to, and the workforce will be overseeing the machines. Maybe instead of having 5 machinists, you'll have 2, but they're supplemented by the robots that are doing the portion of the job that's the machine tending part. Kind of like the self-checkout line. Instead of having 5 people at checkout, now you have 1 watching 5 registers.
Mm-hmm.
So it will need supervision. It will need oversight. It will need to be attended to. Most of these robot companies are far better at remote customer support. So you mentioned it's difficult to find robot programming, and the math used to be 25% of the project was the robot, 25% of the project was the peripherals and accessories, and 50% was the programming. Luckily, that programming cost for an install is far lower, and most of these companies can log into your robotic system remotely and teleop or reprogram or reboot or deal with any downtime issues that you might have. So you don't necessarily need someone on site. I see a great company for that. It's called Olis.ai, OLIS.ai. They can make it so if you're the owner of a machine shop and you have machine tending robots and you want to be a 24/7 op, you can actually go reboot and fix your robot on your phone or on a browser. You can just log in and get it going again. And that kind of access is what companies need in order to feel comfortable automating systems, is that ability to reboot or attend to the robot if it happens to go down. And it will. That's just what it's going to do.
Sure.
Sometimes.
Yep.
Yeah.
Now, you mentioned also about gripper technology, and I think that's been one of the areas that's really had some very interesting developments with some of these unique ones that are like the squid or octopus style, where it wraps around to grab objects of different shapes, number one, but also that can do it in a way so that it does not damage the object it's squeezing. So it can handle objects with less force, because usually if it doesn't grab it, the solution is just increase the amount of force you're grabbing it with, and that may not be the best solution depending on the brittleness of the part or whatever you're trying to grab. What are some of the things you've seen out there in grippers that may be exciting and may be helping people?
Well, I'm very impressed with what Robotics has done, and this is public research by Ken Goldberg's lab out of Berkeley. And people in robotics know Ken. I think he's mechanical, looking at grafting, but modeling the kinematics and force expectations of the gripper, and putting that kind of model through the AI gym, which is doing your machine and your motion planning. This is for the robotics R&D people. They can read Ken's papers and look at the kinematics of the grasping and running that through the machine learning training program as well. So there's this whole new domain. There's the sensor problem. How do you do force control inside the sensor? Inside the gripper. Can that sensor actually survive its working environment? That's not a solved problem, because sometimes they're wet, or there is so much motion that the sensor is fragile because it's compressed every 2 seconds. Yeah. So what I'm learning in a lot of these robotic systems are judged on tick rate, so speed. Mm-hmm. So again, it depends. If you have a low speed application, which most robotics people, except for machine tending, most of them want high speed. And I was actually talking to a food handling robot company recently. They basically designed a different gripper for every type of food that they're handling. and because things get sticky or there's inconsistencies or object sizes. So grippers might be, I'm seeing this more and more one-offs that are application specifically designed.
Yeah. Well, I think that's a big area that these companies have gone into, some of the additive manufacturing where they're actually printing different grippers for different applications, because they are very specific. They're, for a specific part, and it's easier for them to, rather than have somebody send out a print, it comes back, it doesn't work. They're just trying to do it in-house so that they can have better turnaround on their grippers, because most of the the companies that make them are making very generic ones, and if you need something specific, you might have to wind up designing it yourself.
Mm-hmm.
What?
Yeah, and that's not that scary. It depends on, again, there's a lot of roboticists out there who can, or a lot of companies out there who can advise. I think there's 2 or 3 though different types of robot vendors, and what's sad is they don't really know about. There's kind of what I want to call them, the industrial automation integrators who have been around a while. The benefit is if they've done your application before. So let's say you're a bakery, a small bakery, and you want to automate muffins, or if you go to an integrator who has done exactly that job before, they'll know how to do it, and there's a lot of certainty with that, and that's good.
Yeah.
They're not applying the latest technology from the past 10 years. This is unlikely and improbable that they're using 3D computer vision or real-time computer vision or cobots. And then I want to call them these new school kind of robot companies. A lot of them are still in the startup phase, so they're smaller. They might not have as much. They might not have as many case studies to point to, but they're agile. You could bring the robot in and actually try it and test it on a monthly fee, and then send it back if it doesn't work. Mm-hmm. So you have more of an agile method with the new guys. And some people will look at it with a creative mindset, and other people will not. That's why I say you just gotta have to talk with a lot of different types of vendors. However, another issue that I'm hearing is the integrators and robot vendors are so busy that they really don't have. They're prioritizing who their customers can be. So again, this is a benefit to go to maybe the newer companies who don't have as much credibility yet, but they offer a more agile method to get started, where you can just bring in the robot for a few months and try it out. It's a lighter weight system.
Yeah, I think you're right. They have they're more flexible. They're more willing to work with you.
Right.
Erin, we are just about out of time here. Tell everybody how they can find you and how they can reach you.
Sure. LinkedIn. Well, what's most memorable is my Twitter. I'm Robot Diva on Twitter. So, and then if you go to my Twitter, my LinkedIn is there. Erin Bishop on LinkedIn. My maiden name, Erin RAPACKI, is also a really good way to. There's more Erin Bishops in the world than Erin RAPACKI. So searching Erin RAPACKI will get you to me a lot faster. That's RAPACKI. And I do have a little website, machineinbound.com. If you search that will probably lead to me as well.
Machine Inbound. Great. Thank you so much again for your time. Go and make it a great day.
Thank you. Yeah, you too. Thank you.